Welcome to math class today, pre-algebra students. This video is for you to check your work from lesson 92. So make sure you have your work in front of you, make sure you have something to mark with. Make sure that if you have not performed these procedures correctly, that you correct yourself, and make sure you understand what you have done wrong, as well as what you've done right if you get the right answer. Our first problem was number 4. Number 4 is a graphing on a number line problem. They want you to graph all the real numbers greater than -2 that are also less than or equal to 5. So I drew my number line. I put an open circle on -2, closed circle on 5, and I colored in all the space in between those two numbers. Okay, number 6. Number 6 was a sets problem. It said the first set was the first 5 counting numbers and the second set was the first 5 even counting numbers. So they wanted us first to find the intersection of those two sets. That means what elements are contained in both. Both sets have a 2 and both sets have a 4. So the intersection was the set of 2 and 4. The union, we have to include all the elements from both sets. So you should have put 1, 2, 3, 4, 5, 6, and 8 and 10 in the union. Number 7 and 8 were our FOIL problems. Okay, so this is our brand new concept. Okay, we need to memorize what FOIL stands for. First, we're going to multiply first terms together. Outside, we're going to multiply outside terms together. Inside, we're going to multiply inside terms together, and then last. Okay, so when I multiply the outsides, or the first rather, f for first of each, the first term of each expression, x times x gives me x squared. Now outside, x times +3 gives me +3x. Inside, +3 times an x gives me a +3x. Last, +3 times +3 gives me a +9. Now I combine anything that's like. My +3x and my +3x are the only things that are like. They combine to make +6x. So the final result is x squared, +6x, +9. X squared plus 6x plus 9. Number 8. It was a rectangle they wanted us to find the area of on 8. So we used 4x plus 2 times x minus 1 to find the area. Length times width. 4x times x, my first, gives me 4x squared. Then I want outsides. 4x times a -1 gives me -4x. Insides, +2 times x gives me +2x. Then last, +2 times -1 gives me -2. These two, -4x and +2x, are the only things like. They combine to make -2x. So our final result, 4x squared minus 2x minus 2. Our next problem is number 9. That was a 9, 10, 11 actually. Those were all graphing problems. So number 9, they wanted us to graph these points, and it gave us this rectangle here. And then they asked us to find the length and the width of the rectangle. Hopefully you saw that I could draw a right angle off of that length. This side measured 1, 2, 3, 4. This side measured 1, 2, 3, 4. So I used my Pythagorean theorem. 4 squared plus 4 squared will give me c squared, where this is the hypotenuse of the right triangle that I just formed. 16 plus 16 equals c squared. 32 equals c squared. Square root of 32 equals c. And then I broke 32 down because there's a perfect square in there. 16 times 2, I brought out the 4. The 2 remains inside. So this length is 4 radical 2. I went ahead and just labeled it on this side because there's so much over here already. Same thing on this side. I could draw a right triangle off of this side. So I get 3 and 3. 3 squared plus 3 squared equals c squared. My addition here gives me 18 is equal to c squared. Radical 18 gives me c. I broke 18 down into 9 and 2. Then brought out the 3. 3 radical 2 equals C. So the widths on this one are 3 radical 2. So the length is 4 radical 2. The width is 3 radical 2. That is for number 9. Okay. Number 10 asks us, what is the area of the rectangle? So they want us to figure out the area of this rectangle. Well, to figure out area, I do length times width. So I did length times width. 4 times 3 is 12. Radical 2 times radical 2. Those can both go under the same radical. That gives me radical 4. I'm sorry, my camera keeps slipping. So I end up bringing out the 2. 2 times 12 is 24 square units. Okay. Now number 11 was kind of weird. Number 11, they asks us what would be the measure of the diagonal. So they want us to figure out what this length would be, and hopefully you saw, well, now we've made another right triangle, okay, where this is the one leg and this is the other leg, okay. So we're going to use our Pythagorean theorem again. The square of one leg plus the square of the other leg gives us the length of our hypotenuse. So now we're calling this diagonal the hypotenuse, okay. So 3 radical 2 squared, my 3 is squared, I get 9. I do radical 2 times radical 2, that gives me radical 4, plus 4 radical 2 times 4 radical 2 is 16 radical 4, and that'll all be equal to c squared. This is a perfect, the root comes out, 9 times 2. This is a perfect, the root comes out, 16 times 2. 9 times 2 is 18 plus 32 is equal to c squared. So 32 plus 18 gives me 50. 50 is equal to c squared. Radical 50 is equal to c. And I can turn radical 50 into 25 times 2, and I have another perfect square. So that root can come out, and I end up with 5 radical 2 for the answer to number 11. Okay? So now we are on to number 12. Number 12. Number 12 says to write an expression for the perimeter of a square if the sides measure 2x plus 1. Well, the formula for perimeter of a square is whatever the length of the side, I can multiply it times 4. So they give me the length of the side here. So I'm just going to distribute 4 times 2x plus 1, and I'll end up with 8x plus 4 as the perimeter of my square. Okay. Number 15. On number 15, they ask us if the measures of this triangle could be the measures of a right triangle. So we use our Pythagorean theorem, which we've done a lot of today, and we do radical 5 squared plus radical 5 squared, and we put it equal to radical 10 squared and see if it's true. Well, if I square radical 5, I get 5, and another 5. If I square radical 10, I get 10. 5 plus 5 is 10. 10 is equal to 10, so it checks out, and we can say yes, these could be the measures of a right triangle. Number 16. We have a conversion problem here on number 16. They give us 240 cubic feet of concrete, and they want us to turn it into cubic yards. Okay? Feet cubed means I've got to use 3 unit multipliers to get rid of feet times feet times feet. So I'm going to use 1 yard is equal to 3 feet. I'm going to do it 3 times. So my feet cubed, I can get rid of them and just end up with yards cubed. Then I have 240 on top. 3 times 3 times 3 is 27 on the bottom. 240 divided by 27, I get 8.8 repeating. So you're going to have to order 9 yards of concrete. Okay, number 17. Number 17, they want us to find the perimeter and the area of that trapezoid. Well, perimeter, we just add up the outside lengths. And you should have gotten that the perimeter is 20 meters. For the area, our formula is base 1 plus base 2 divided by 2 times height. Remember, your bases are the parallel sides. Okay? 8 and 2 divide by 2, you get 5 times the height of 4, 20 meters squared. Our next one was number 22. We have a distribution and a solving for x problem. Okay? 3 times x, you should have gotten 3x. 3 times positive 2 is positive 6, is equal to 2x plus 15. Now I want to get my x's together, so this is a positive 2x, so to move it, I can subtract 2x on both sides. This is gone now on this side. Now 3x minus 2x leaves me with 1x, plus 6 is equal to 15. Now I want to get my numbers together. So I'm just going to subtract a 6 on both sides. Subtract a 6 here. These are gone, which is what I want. 15 minus 6, x is equal to 9. Okay, number 23. They give us 2 cubes, okay? They want us to find the volume of each cube. So I did the smaller one here. Our formula for volume is the area of the base times the height. So I did the area of the base times the height. On the small one, it's 24 inches cubed. On the larger one, area of the base times the height, you should have gotten 192 inches cubed. Now we use that information to help us on number 24. Okay? So on number 24, A, it says, what's the scale factor to go from the smaller to the larger? Well, if you look on there, each length on the larger cube is twice the length on the smaller cube. So our scale factor is 2. On B, they ask us to give the ratio of the area of a face of the larger to the face of the smaller. So I did the area of just the front face on the larger is 48 inches square, compared to the front face on the smaller was, this is area, so the smaller one was 12. So then I just reduced, and the ratio is 4 to 1, which I hope you remembered that if we were comparing our area of the different ones, it would be the scale factor squared would be the difference in the ratio. Remember? This one, on C, they wanted us to compare the volumes of the bigger to the smaller. So I did the volume of the big one compared to the volume of the small one, which is what we did in number 23. And then I reduced, and the ratio is 8 to 1. And if you remember, we take our scale factor and cube it to get the ratio of the volumes. Okay? Hope you did well. Hope you have a great day. And I will meet you right back here next time. Bye, guys.